we all doing? Good to see you. Happy 2022. Hope it's been a good start for Gophers alike. Very, very busy here at the Towers, and really pleased to have our first e-meetup of the year. Klaus Post, as you've probably seen some of the updates, he's got his talk on serializing data in Go. Really, really excited for this one. We've got some great numbers. So as usual, just going to let the room fill up a little bit. You can scan the QR code. Remember to scan the Slido code below so that you guys can access all of the Gopher card quiz games at the start, as you know, and it'll allow you to answer and ask some questions to Klaus throughout and participate in the event. So scan the QR code for Slido.
Yeah, scan the code, guys, or jump onto slido.com, #serializing. Also, remember, if you haven't attended before, you can submit some questions during the talk. Might be something interesting that Klaus is talking about. We'll have the opportunity to get to a couple of questions, time permitting, at the end, and get a bit of wisdom from the main man himself. So looking forward to that too. If you haven't been involved before in these meetups, guys, just to give you a quick rundown on the format. Once everyone's jumped in and added onto Slido, we'll start with the Gopher card game. And this will take roughly 5 minutes. There's a prize giveaway of, you can probably just see it creeping in shot here, the old Gopher playing cards, very coveted, prestigious prize. And then we'll hand over to Klaus, who'll do roughly half an hour talk on data serializing in Go. We'll do a quiz that Klaus has put together, also with some giveaways. This will be general knowledge around Golang, so should be some good fun. Couple of questions, and then we'll wrap things up from there.
Yeah, I think it'll be around 45 minutes, maybe a little bit longer today. So we'll have you guys back at lunch. So no dramas on that front. But as Joe said, I think everyone knows the format by now. But if you don't, I can't reiterate enough. Get on Slido so that you guys can participate in all of this event, okay?
Yeah, plenty of prizes up for grabs. And obviously you want it to be as interactive as possible, guys. Get your questions in. If you really like a question, you really want that one answered at the end for Klaus, just give it a like and we'll get to those questions with the most likes from there. How are we doing on numbers, Kate? 11 in on Slido. So we'll just give it a couple of minutes. Just jump on, guys. We'll get into the Gopher card game and then straight into the good stuff with Klaus from there.
Brilliant. A couple more minutes.
But yeah, for those that don't know, we are the Joes, Joe and Joe. We are the practice leaders, directors here at GoNaviro. We're a team of consultants based out in the Americas and here in Europe that focus exclusively on Golang staffing solutions. So if you guys are in the market, you wanted some information on the market or any positions out there, we're your men. We'd love to talk to you. We also have a Gopher campaign, which is basically where you refer other Gophers that may be interested in remote or relocation work. One of the guys, Jeffy, who attended one of our meetups recently, referred through a Gopher. We've just got him his friend a role in Berlin with a big cloud vendor. So big bonuses for everyone involved. You can check out the details on our website under the referral tab, gonaviro.com. And yeah, we'll start cracking into the game. How are we looking, Kate? 15 in there. All right,
okay,
lovely
good stuff. Well, I think we can jump onto the next screen and start the Gopher card stuff presently. Right, let's get it going.
Right then, share the screen. Let's get into the quiz.
Brilliant. Right, here we go. Raminus, Superhan. Good to see those two jump in. Keep scanning that code in the corner. As you can see, the Slido down there. Brilliant. These numbers are going up. Here we go. Natalie's in. Great to see you there, Natalie Ravenhill. Fantastic. Right, these numbers are jumping in quick. We're going
Matt Harrison, Artem. Right, nearly ready to roll. Klaus, are you taking part in this one? Are you jumping in on it?
I'm not sure.
Just the higher or lower or the same are the options, guys, after you see the cards. These were dealt out today. They are legitimately random, so don't hold it against us, depending what the outcomes are. Best of luck to everyone. Kick things off now.
Brilliant. Go on then, let's start. higher or lower than a 7? Nice and easy to kick it off.
Higher, lower, or the same,
we
guys?
always do an easy one down here. Higher or lower than a 7? What we got? Pretty much a 50-50 split.
It was a 6 of diamonds. Little magical gopher there. 6 of diamonds. So it was lower. 43% of you got that right. Right.
Next one.
Higher or lower than a 6? Or the same than a 6?
Higher or lower? Or the same. Yeah. Okay. And we know those sames come up a lot more than you think. So go on.
All right. Answers in.
2. Good on, yeah, nice and easy. I like the 14% going with the same. I'd have gone there. I'd have done the same. Lovely. Right, higher or lower than a 2? This should be an easy one, everyone. Quick countdown.
Higher, lower, or the same than a 2.
Yeah, of course.
There you go. 100% there. No curveballs.
Back to a 7. Lovely.
7 ball. Right, we've got 2 to go, guys.
Higher or lower than a 7? These are all, as always, completely random generated.
7 seconds. Get your answers in, guys.
Higher or lower than a 7? 3, 2, 1. Where have we gone? 60-40. Go on the 10 ball. Lovely. 60% of you guys getting it right this time around.
60.
We'll have a quick look at the scoreboard.
How are we looking?
Anna.
Congratulations,
Anna. 4 out of 4.
Good, looking strong.
Natalie, just behind. Look at that.
Just 1 hurdle to jump. It is done on speed as well, guys. So some of you are packed in quite close there. Get your answers in as quick as you can. We got Anna by Natalie by Peter.
One more to go. So it was 10. Higher or lower than a 10 for the final question. We will ask. Higher or
lower, or the same. Don't forget the same. It's an option there. It does happen. I'm not saying it will happen. Higher, lower, or the same. Get your answers in, guys.
Go on. Big reveal.
86% of you got it right. It was the 8 of spades. Little Batman Gopher to boot.
Batman Gopher. So who's getting the Natalie?
Oh, Natalie snuck in, right?
Did all right.
Nice work, Natalie.
Peter and Anna very close, but it's going to be Natalie. Yeah, it's only a second. Yeah, very, very close. Yeah, Peter, only missing out by a second. So Natalie, the prestigious Gopher cards are on the way to you. We'll get your details after and have that sent out to you. So really well done with that. Congrats.
Strong stuff. All right, perfect. So we'll be jumping off now and we'll leave Klaus to carry on with his talk.
Yeah, catch you guys at the end.
We'll catch you guys after.
Hi, folks. Hope you got some good stuff in with the with the part guessing game. So yeah, I'll be doing a talk on serializing data in Go. We'll look into designing and evaluating and looking into the various options that are in there. There will not be any "this is how you should do it" kind of things, but it will be a general guideline you can hopefully take with you and use in your everyday adventures into various programming. So why do we do it, first of all? So we do it to exchange data between applications. We do it for RPC calls to send parameters, receive them back. We use it to persist in-memory data. If we want to persist it to disk or in the database, something like that, we work with that. We use it when we query different sources and want to collect them into one. It could also be MapReduce, so something like that, where you pull in different streams and save them. So it could also be for caching. So that is basically making existing data. So if you have a SQL database that you're doing queries to, maybe you want to store the results so you can look it up faster next time you need it. So yeah, that's basically what it is. So if we look at what your application has in memory. So we have a struct, we have an instance of it where we put in an ID, TTL, various different values. This is then represented in the computer memory as binary data, and it looks like mumbo jumbo. So you can see the ID is clearly the first one, and 42 is the 2A, stuff like that. Thing is, it's depending on the architecture you're working with, this representation will be different. So you can't just dump it as is and read it back and expect it to always work. So that is why we simply look into serializing data. An example could be we could store it as JSON. Most of you will probably know this already. So we have a key and we have a value, and we have different formats for each data type. So basically, it's able to be read back and restored into memory rather quickly. So we have pros and cons of each. So JSON is platform independent. It has a schema. It has the keys for each for each value that you store. It is extendable. You can add more fields without breaking it. If you just dump memory, then you have to do all kind of weird stuff to stretch it. So you wouldn't do that. You have some integrity checks in JSON, so it has to conform to the JSON standard. If it doesn't, then it will error out. It's standardized. How it's represented in memory can differ even from version to version. The size is small to medium in memory, and is pretty verbose in JSON. Memory, you can dump it, you can read it back, you can hope that it works, but you don't really have any tools to inspect it unless you write it yourself. Of course, just plopping back memory and into a struct is fast compared to JSON that requires you to pass it. So you can talk about the schemas. So if you, this is Captain Proto, where you define the schema of your data outside of Go. This is a file that you then compile, and it then outputs the Go struct that matches this. This is also the same for flat buffers or protobuf. So that's a way of doing it. The main thing is that the main benefit of that is that it can compile to different languages. So if you need it in other languages than Go, then that can be an advantage for you. If we go back to the JSON, we have the keys in the output data, so to speak. You don't get that with the precompiled stuff, because it just assumes that the first value will be ID, it will be this long, etc., etc. And then you get into versioning and all those. Let's look at a few examples. So we have a value of 1000 that we want to serialize. As JSON, you would typically wrap this in an object with the key. If we look at the value itself, then we have 4 bytes, so 1, 2, 3, 4, and you have a separator. So each value you store, you have to separate either by a comma or a close bracket or something like that indicates this is the end of the value. So obviously it's quite easy to read. We can see immediately what the value is. So that's a really nice property of JSON. If we look at message pack, we get 3 bytes out from it. So the D1 indicates the type, which is a signed integer. and then the value is stored in the second 2 bytes as little endian. So when you see a D1, you know I'm dealing with a signed integer, and the following 2 bytes contain the actual value that I'm looking for. So that's a binary representation of it with a type. If we look into there's alternatives. So you can also store it as an unsigned integer and 2 bytes. It's pretty much the same. The value is the same, but you tell a bit more about what type it is. You also have one byte, so it's from 0 to 255, which then has another identifier, and similar for 4 bytes, etc. If we look into just pure binary, then if we say this is 16-bit little endian, then this is the representation, it's 2 byte. But you have to know that it's 16-bit, you have to know that it is little endian, and to be able to read it back. You don't get any extra information, and you need to have that knowledge beforehand. If you use variable integers, you have a bit more flexibility because it's variable length. So you can actually store any 62-bit value in this, and it will just stretch to get longer as the number gets bigger. So you take all the serializers that exist and try to classify them broadly. So you have the memory representation, the raw binary on the left, where you assume how it's ordered, what the keys are. It's binary, so you can't just list it easily and see what it is. Typically, it's quite small in size because you don't store all this extra data. It can be tricky to add more values to it, and since it's fixed, then you have to do some versioning to make it work. So obviously, it's not as easy to use as going into, for example, JSON. It could also be CSV or the text-based, where you have the schema as the structure, and you have the keys to say this is what each value represents. It's readable. You can list it on the screen. It takes up a bit more space. You can add values. You can also remove values, and typically it's also slower. It's pretty much always is, but it's pretty easy to use. So that's kind of the spectrum you're working with the very techy, hard to use stuff to the easy and to the easy stuff. Here's some actual examples of this. So you have the generators that generate code for you, where you define the schema outside, and you use that. You could also, if you write just binary data, that's kind of the same. You have the in between, which is like the message pack we looked at, which is binary but has some type information. Same for GOPS and BSON, which also helps, but it's not. You can find tools that can list it for you, but you can't just cat the file and see what's in there. Then you have XML, JSON, CSV, text-based. Most of you probably work with these on a regular basis, so they are pretty handy to have as well. So which one is better? I already kind of spoiled this. I'm not going to tell you which one is better because it depends on what you need it for. So some consideration into when you had to choose a serializer for a particular task? Is it a standardized method of serializing, or are you inventing something for yourself? I'm not going to say you should never invent something, but reusing existing stuff can sometimes make it a lot easier when people have to pick it up at a later date and work with it. Does it have to work cross-platform? So are you using tools that are only available for one or just a few platforms? That's pretty important also. How are the tools? Are there tools out there that can help you see the data and serialize and deserialize in easy way? Can you extend it? Can you add new stuff? If you it pretty much always comes up that you have to add information to it. So how easy is it to extend that? How much pain are you going to go through for that? Can you use it for streaming? That's not always considered because it can be in a lot of cases you're dealing with gigabytes of data or even more. So it's important that you don't have to load everything into memory to process it and to spit it back. That's pretty easy. Can be pretty important. If it's just small cached objects, it's not that important because you're going to read all of it into memory and so forth. How fast is it? Pretty important when you're doing caching, things like that. How big is the output size? Does it take up a lot of extra space? Does it save you a lot when comparing them? That's probably some of the most important things. You can also have specific needs that you need to cater for. So that could also be important for you to look at. So let's take an example of a task I had a few months ago. So what we have is we need to represent a bunch of file metadata. So it can be this is for listing directories that we have to send back. So it has to stream because you never know how many you're gonna need to have. It needs to have basic file metadata. It has to be pre-sorted by name, and there's various custom fields that we need to include in the metadata. We want to be able to extend it with more or less information as time moves on. We want to be able to filter by name. Effectively, that also means we need to be able to quickly forward to a specific entry. So if we have the directory listing as a stream that we know is pre-sorted, then we need to quickly be able to skip forward to a specific entry, so we can so we don't have to pass everything in between. And also we need to know, do we have a complete listing? Are we actually at the end of the stream, or did it just happen to end right now? That can be pretty important for consistency and making sure that your systems behave in a predictable fashion. So first of all, what we did is that we started by encapsulating the metadata. Basically, each of the fields. Let me see. Each of the fields we compact everything but the name into a pre-marshaled byte array. So we know the name and we can quickly check, does this name contain whatever we are interested in, or can we just should we just skip the metadata and move on to the next entry to search for that? So basically, when we have a bunch of files, we write the name, we write the as a string, we might write the bytes or the metadata as raw bytes. Reading it back, basically, as long as we have more input, we send back a file with the or a file object with the name and the metadata. I mentioned unescaped binary because when we need to just skip the metadata and move on to the next file, it's very important that we can just skip it and not having to read anything in between. If you take JSON, for example, you can't really skip passing stuff. So if you have an object in your JSON that you're not really interested in, then you still need to pass all the open brackets and close brackets and quotes and non-quotes to be able to forward to the next entry. So that is why it's pretty important that we can just skip the binary data and move on to the next one. So we start out writing, defining a stream version. It's quite important that you always define your data version before you start writing the data. That way you can upgrade it, you can add new fields, you can remove them, and basically if you do it on the second version, it's already too late, because if what you write doesn't have a version for version 1, then checking if it's version 1 or version 2 can be quite tricky, because the first version can basically just starts with the data, and you don't know what is coming. And it could be, if you write a number, the data could just happen to start with that version number, version 2 or whatever, and you pretty much wouldn't be able to know. So we range through the files that we want to write. We write a bool, basically telling us there's more entries to come. We write the name and we write the metadata. When we're done, we write a false to indicate this is the actual end of the stream. So that is, again, so you know that you read all of them and that it didn't error out in the middle. Connection, whatever could happen. Maybe the file was truncated, stuff like that. So basically, you have a clear end of file marker. Writing a bool is pretty fine. It could also be something else that indicates end of stream, but for most, it's just a single byte that you add to the output. So unless you have not even millions, is going to be a big issue for a single byte. Considering that you also add pretty much a lot of data with the name and the metadata. So an example, you need to consider how are each of these written. So I wrote up. This is not what we actually use, but just as an example, write a string. So we define a limit. This is the maximum length. We store the length as a little engine, and we append that to the output, and then we write the bytes that the string contains. So this is an example. Might be good, might be bad for your specific case. So some of the things to consider when you're doing this. So header, you can have like a big magic header, 5-8 bytes, whatever. Maybe that's a good thing if you need if you just need to be able to identify it later. Always add a version, as I told you. Sometimes a checksum is a good thing. It doesn't need to be like a 32 bytes, a huge hash or something like that. It's just enough that you can tell if the data has been modified. Um, skippable blocks can be a good idea to predefine a way of skipping data from future versions, so you can add stuff, but it's just ignored by the previous versions. Explicit end of stream. Allow concatenating streams in an easy way. So so if you have different, you can append those pretty easy with the and basically when you send the input, it's able to assume that. Of course, you shouldn't be able to set any input that crashes it. That's pretty much a given for any format. And keep track of whatever huge allocations that you're doing when you on Marshall. If you have to on Marshall many megabytes of data that could be to get to a single value, that's a problem. Make it easy to do concurrently. So in the directory listing example, you can basically cut out the metadata and do the metadata decoding asynchronously. So that can definitely help. So there are some API. The standard library has Marshall binary and Marshall unbinary interfaces that basically enables you to get the data as a byte array that you can then store. I personally prefer where you append to a destination. That makes it a lot more flexible, so you can easily embed into other objects, and you just append to existing data. So if you just want the single object, you just send a zero-sized destination, and it will be as if you didn't do that. Same for the unmarshal. It unmarshals the object and then returns whatever remains on the after it has consumed the bytes that it needs to do that. So, for example, TinyLib message P has some primitive serializers. So you pass in a byte array that you are appending to, and you want to append the bool, and it basically returns the modified byte array. So you can just keep doing that. There's for a lot of different types. For reading back, you provide the byte array. It returns the value. It returns whatever remains, and if it wasn't a bool, then it returns an error. Similar for the other types. It performs code gen for structs, so it will generate code to Marshall and non-Marshall entire objects. So for streams, you can have different. It depends on what you need. So for this, for example, it would be for the directory where you can send in files to be serialized, and it will serialize it and write it to the router you provide. For deserializing, you provide a reader with the input, and you provide a callback for every object that you then get back. That's something that's fixed. You could also have a dedicated reader writer that keeps track of the stream, and you just send each object as you want to serialize it. So streams in message pack is kind of similar, where you create a writer and you say, now write a bool to the stream, now write a byte to the stream, and similar in reverse. So you have a reader, you read the bool back. If it wasn't a bool, you get an error. you read the byte back. So this gives you some options for that. And again, yeah, it has quote input strokes. Let's look, for example, the message pack types. So you have different types that you can represent. It's not, you can't put anything in there, but you do have, just like JSON. It's pretty much the same as JSON. So you can have maps with which is objects with the string keys. When you see it, you just get pairs of key object, and therefore it's very hard to you can't just, similar to JSON, you can't just skip it unless you know the size. You have arrays with a known element count, but you don't know the actual size on the stream, and then you get into the even more primitive stuff where you have just binary data. This on escape, you know the size, you have strings, you have integers and signed and unsigned, bools, floats, and nil values. So you can, similar to JSON, you can represent null. And you have extensions which cover things like timestamps. You can also do your own custom extensions. Compression, quickly. You have two main options. So you can either do it as individual objects. Again, here we have the files, and we write the metadata as compressed. So it's still, so the overall structure of the data is uncompressed, but the thing that takes up a lot of space we compress, and we simply indicate whether it's compressed or not. You can also do full stream compression. Again, keep the version out of the compressed stuff, and then simply write how it's compressed, and then whatever follows will be compressed. Both have the individual elements takes up a lot more space than the full stream, because the full stream can compress across each of the entries. So typically the full stream will be a lot smaller in your output, and you can pretty much choose what you want in these examples for this. So yeah, tests. Keep regression tests and collect crashes as you see them. Maybe have a zip file with the things that have previously crashed, so you can quickly retest those. Do fuzz tests, and again collect the input. It can be hard. Of course, decoding is easy. Encoding could be a bit more tricky, so maybe you want to decode the fuzz input, then encode it, and then decode it again to see if you have any inconsistencies there. Benchmarks. So yeah, quickly, don't do this is better than this, because it depends on your data, it depends on what you need it for. Don't just test on a single struct. Test on the actual structure you'll be needing with the actual values. Use different values. Don't just use one value and keep repeating that benchmarks. Consider allocations. Include allocations. Don't include them. It can be. It's important that you know whether your benchmarks include allocations or not. Allocations will happen when you use it. On the other hand, it might also be so dominating that you're not actually testing what you're looking in. Finally, a very common mistake is that you add the speed of your benchmark as megabytes per second. That doesn't make sense if the output size is different. So if you're comparing message pack to JSON, message pack would be much smaller. So it has to, you have to, it doesn't really reflect how many objects you are processing per second. So use that as the metric. Yeah, make it clear, realistic, real data. Reduce avoidable allocations. So if you don't, if unmarshalling doesn't need allocations, then test without that. But of course, you shouldn't fake out the ones that are actually needed. Oh, sorry. So yeah, evaluate data size. Do that outside of benchmarks typically, because yeah, it's size and speed that are the important parts. Good. Quickly, some recommendations. JSON, easy to read. We already went through that. Can be verbose. Always require parsing. Escape characters. Reflection overhead. GOP is used a lot for Go, but it only applies for Go. It's convenient. It's easy. But it's also not always the best option, and it has some reflection overhead. The generator stuff, binary, static code gen, wide language support, compact, typically fast. It's out of stream, so you need to handle versions, compatibility. Tooling can be tricky, at least in my experience. The compilers are not always as easy to work with, and it doesn't always output good Go code. So actually dealing with the output from them can be a bit tricky. Message pack, yeah, we pretty much went through the pros and cons of it. It's pretty much like JSON, but more compact and in a binary format. So typically a bit easier. Fully custom, you write your own. You have full control, but yeah, there's a lot of things you need to take care of when you do it yourself. I prefer a hybrid do-it-yourself. Utilize tools for complex structures, and then add single values to that. And I tend to prefer type safety, so we include the types of the values we are doing. Start writing the deserializer. Often that's a way easier to get an idea of how it should be actually written. Yeah, keep future expansion, document well. I love using message fee, as you probably noticed. It's pretty good for these hybrid do-it-yourself. And yeah, sometimes JSON for CSV is actually fine. It doesn't always have to be super technical and hard to use. So yeah. Here's an example of I put up on the Minio blog, where go into how we designed the storing versions of S3 objects in S3 object store. So yeah, I hope you'll check that out if you're interested in these kind of things. So yeah, good luck, have fun, and thank you.
All right.
Big thanks there, Klaus.
Are we back in the room here?
Back in, yeah. Really, really good chat. That we're getting some great feedback already. So big thanks there, Klaus. That was class. Really, really well laid out. And look, we'll be getting that recording all put together and out to the other people that couldn't make it today. So I think without further ado, we're going to go into the questions that Klaus has prepared.
Yeah, so these are general knowledge questions, guys, that Klaus has kindly put together for us. So I'm sure a lot of you guys should be confident on general Go knowledge, but we'll see. Again, I think Sorav posted in the group that it was a bit miffed that he missed out on the card pack here. So here's your chance, mate. There you are, Sorav Patanik. Good luck, buddy.
Yeah, he's
Up
in
for
there.
grabs.
This is a bit more skill-based. That's could be an advantage.
For some of us, maybe.
At least I hope it is.
Yeah. Get in there quick, guys. Scan that code and make sure you're in for this. We'll be kicking it off very shortly. You'll have 20 seconds. So when the questions appear, you'll have 20 seconds to answer it. I'll be reading them out as well, but the questions will appear on your screen. So just make sure you're ready to go. And remember, not only the right answer, but if you answer quicker, you do get more points. So don't rush, but it is timed.
Yeah. Don't take too long. If it is tied at the end, it will come down to speed. Natalie, I think, was the winner. Is that right, Joe?
Natalie was winner last time. Anna was just pipped to that one. So it could be double deck of cards coming to you, Natalie, if you pull this one off.
Cool. All right. Nice. Let's get into it, guys. Katie, if you can share the
ready
quiz.
to go? Yeah, you've got 20 seconds. Remember, guys, I'll read this one out. But when was Go publicly announced? November 2009, September 2005, October 2007, or December 2011?
7 seconds, guys. Get your answers in.
You should all know this one.
Interested to see the results on this one.
Oh, big shout for 55% of November, which was the correct answer. Well done.
November 2009.
December, a bit of a curveball there in 2011, but
all right, let's roll on to the next one. I'll take this one, mate. When was Go 1.0 released? Was it March 2012, December 2010, June 2011, or April 2013? Go 1.0.
Nice and easy, this one.
5 seconds, guys. Get your answers in. This will be 5 questions.
I'm pretty sure that
general Go knowledge.
June. I was going to go June 2011, and I would have been wrong.
March 2012. Now, what percentage got that one right? 29%. Okay, it's pretty much a third of you. Strong work.
Good stuff. Next question, guys. Go on. How do you inspect a captured profile in Go? Is it Go Tool Inspect, Go Tool Vet, Go Tool P-Prof, or Go Tool Dump? And apologies if they were all mispronounced.
A little abbreviation there, mate. All right.
Good.
Is your favourite? The Go Tool P-Prof. 75% you got that one. Nice work, guys. Solid knowledge all round there. So
Brilliant.
Question number 4. Let's roll into it, please, Katie. In the standard library, the native type of os.stdout is io.writer, io.writeCloser, io.pipewriter, or staros.file. 3 seconds, guys.
Another easy
Getting technical
one there,
now.
guys.
Very
Yeah,
technical.
very technical. I'm not reading that one out. IO Writer seems to be the overall favourite, but it's not.
Wow. 15% of you got that one right. That's interesting.
I'd like to see it. Well done, that 15. I'd like to see who that was. We won't shame the others. Brilliant. Right. Next question, I think.
Final one.
Leaderboard. So, Maxim in the lead.
Oh, yeah.
Natalie again. Wow. And Anna. Natalie and Anna smashing this today. So, we're really well done. But Maxim in the lead.
Right. Good.
By 5 seconds, though. It's both 3 out of 4. So, final question. This is it. Your chance to stay on top, Maxim. Let's see. In Go, new is a keyword, a pre-declared function, an operator, or literal.
There you go.
In Go, new.
8 seconds. Get them in quick time. Could all come down to the speed here. Last few seconds, guys.
I'm going to find out this one.
What are you going for?
Keyword.
Operator.
Keyword.
And the answer is
pre-declared.
Well done.
50%. Nice.
Well done.
Good strong
Let's
questions
see,
there, Klaus.
Maxim,
He's held on. 4 out of 5 right. So won it outright. Most answered correctly.
That is on your way.
Yeah, we'll get in touch with you, Maxim. We'll ping you out a limited edition Gopher card, playing cards pack. Well done to everyone else who took part in that. That was, close run race at the end. But the deserved winner, Maxim. So nice work, guys.
Brilliant. So we've got time, I think, for a couple of questions to Klaus. Some have been asked Joe, you want to kick off the top one there?
All right, cool. So Brian, do you know a good library for protobuf where you're able to serialize and deserialize messages using proto files without having to compile the proto into Go?
Not really, to be honest. So I it might be out there. I haven't seen it. But yeah, that is the tooling is probably the hardest part. I know some people are working on building improved tooling. I've heard rumors about it. Not sure how much I can say, but I know there's people working on making it easier to work with. I tend to not go that route unless other tools I work with pretty much require protobuf because it's a tough tool chain to set up, at least for me. Maybe I'm not good enough.
Well, you never know if anyone's got any insights on that. Maybe there is no smoke without fire, and there could be any insights. You guys, please do share them around. And thanks for your question, Brian.
Yeah, Peter T. He's very appreciative of the talk there, Klaus. So you got number one fan. But he said, you may have answered it already, but when deciding between flat buffers, photobuf, cap TN proto, etc., for speed, performance, size, do you ever have a favorite, or do you benchmark each one for each strict?
Yeah. I tend to try to see what we depending on how critical speed is, because in some cases it's not the critical part of it. I actually haven't done a lot where I ended up using any of these three because there wasn't a need to go that deep, and we didn't have to interface with different systems that required them. If you do that, if you're doing that, then you pretty much already have one selected for you anyway. So I haven't really done deep analysis, but I can only recommend benchmark with existing data that you want to transfer and check how does it work, how does it perform in terms of size and speed. So yeah, I'd actually say if you may have one that you've used before, so yeah, just stick with that. They're not that different, but if you really want to present the best option to your team, then benchmarking with your real data is the way to go, in my experience.
Nice,
Brilliant. Yeah,
cheers for that, Klaus.
There was one other question. It wasn't submitted through Slido, but we'll allow it on this occasion. We'll allow it to come through.
It pops up here in the Q&A.
Right.
Tricky to access it though.
We might not be able to allow it, unfortunately. Can we bring that down? Just click down. Does that work?
I got the answer here. I can
can you see it there, Klaus?
Yeah. So Eugene asks how metadata format is different from message pack. This goes back to a specific slide. So what we did there is that when we embed the metadata, we do serialize it as message pack for each file. But the difference is when we store it as a binary blob, we know the size of the blob and we can just skip it. If we embedded it as a message pack object, you will have to pass through every object key and value to know when does the next object start. So that's the main difference, that you pretty much store the same data, but you also include this is how many bytes you have to skip to get to the next one. That's the difference between embedding it directly and embedding it as a binary blob. Hope that makes sense.
Brilliant. Fantastic. All right.
So, Eugene.
Hopefully that clears that up for you, Eugene. Appreciate your time today, Klaus. Really, really good talk. Sure. And yeah, very, very generous of you to share your wisdom. And this what the Go community is all about. I've always found, having worked a number of different technologies, the Gophers out there, they're always happy to share, and great community. So really good having you guys on as always. Bit of fun, and hopefully, got some good tech value out of it as well.
Yeah, I hope so.
Absolutely. Maxim, Natalie, you'll be getting your cards in the post. So get across your details to us. And for everyone else, really well done. You will have another chance to win on our next e-meetup. We will be releasing the schedule for that in the coming weeks. So stay tuned to the GoNaviro website, the GoNaviro LinkedIn page. Remember, all of the information on our Go referral campaign, how you can recommend friends and Gophers that you know about for all of the jobs that we have. You both benefit financially from it, and you're also able to get all of the information on our website on the upcoming videos and everything else.
Yeah, good stuff, guys. Yeah, one little feature that we're going to be doing soon is going to be an in the hot seat with as well. These are going to be very short and snappy, kind of 10-minute chats with some questions for leading Go engineers. So yeah, we'll share some info on that. If you have any questions in general you wanted to submit, we'll do our best to get to those with the Go rock stars out there. But again, thank you so much, Klaus. Really appreciate it. We'll put together a video so we can share this on the website for any friends that may have missed out, or if you wanted to go over some stuff. Keep an eye out on the GoNaviro LinkedIn page or check our website out, and hope to catch you guys soon.
Great. Take care, Klaus, and see you later,
Take
everyone.
care.
All right.
Take
Bye.
care.
Enjoy the rest of your week, guys.
Bye.
Catch you later.